Okay, our next speaker is Joe McFadden. Joe McFadden is Associate Professor at Cornell University and leads the Accelerating Livestock Innovations for Sustainability program there. His program is focused on developing enteric methane mitigation and monitoring solutions for livestock production systems globally. Specifically, his research program aims to define safety and mode of action of methane-mitigating feed additives, that's important, and to enhance the efficiency of milk production, both in, I guess, the US and India and elsewhere. He's teaching courses on enhanced student understanding of biological mechanisms that influence nutrient use in the cow. So welcome, Joe.
Thank you. Okay, so who in here has, I guess, used green feed or looked at green feed data, looked at reports that had green feed data in it, or any other kind of way to measure methane? Raise your hand up, real high, okay. Now, how many of you have confidence in the data? Keep your hands up. Okay, just a couple of you. I want to know what you're using, okay? Let me know. I think that's sort of where I went into this about a couple years ago, is really understand like how confident am I in the data that I'm getting, and what could I do better as an investigator to make sure that I'm getting reliable data? And that's a hard question to ask, and it's constantly evolving. So yes, I am part of this program that we helped create a few years ago, involved a lot of investments in this space. We sort of, as a department, thought about what our priorities are going to be in this space. Obviously, number 4 relates to the topic today, and that's thinking about methane sensors and biomarkers, or how to measure methane emissions in livestock. Obviously, dairy cows are probably our species of interest at Cornell, but we do work in sheep and dairy goats as well. It's fairly limited, but those things will probably evolve with time. I will say that I think last year I might have presented this. We had Ananda Fantora. Dr. Fantora is now a postdoc with Mike Van Amberg, and we had did a meta-analysis. Acquiring data is a difficult thing to do. Reality is there's a lot of data on this planet, and when it comes to green feed data or other sources of ways to measure methane, but not everybody wants to give it. Most people don't want to give it or can't give it. And so we really thought, like, how can we start to investigate these relationships between respiration chambers, SF6, and green feed, just really start to do some preliminary work before our chamber system was open. And we acquired some data. It surely was not enough. We have plans to dramatically expand this here. But in this particular meta-analysis, we got about a 51% agreement between chamber data and green feed. I think it's rather limited in terms of the data set. I can be very critical of myself in that capacity. But it was really trying to sort of say, okay, what do we need to do to maybe improve that? Why is it 51%? Or what are some of the variables that are influencing that outcome? And so moving forward, we wanted to have this 2-step protocol. And we do this now for a variety of methane sensor technologies using our chamber system, whether that be layered independent or dependent on sort of looking at feed additives in our chamber system. So the first step is a mass flow controller where you sort of release the gases at different release rates. And step 2 is this in vivo testing using a switchback design. And I'll go through a couple examples of that. So the chamber system opened up last April. We've been at full capacity since then. We're full capacity until January. Probably next year will be about 250 cows per year that will run through that chamber system. And that involves not just looking at methane, but looking at energetics, nutrient digestibility, carbon nitrogen analysis, milk composition. There's a lot of data there. And there's 4 of those units. They're climate controlled, so we match the climate to the outside. They measure gas emissions every minute, but it sort of cycles through the system in a way that you're getting 2 minutes of measurement per chamber every 10 minutes. We then thought, let's go ahead and compare that to green feeds. And so I'm going to go through some new data with you all, and I think this is hopefully set up the basis of some good questioning later. The first experiment, we're in heifers. Heifers, they're temperamental. We know that, and we moved them into the facility. They're low emitters, though, and so we had, in this particular experiment, 8 Holstein heifers, 5 repetitions, 6 days each. We had 3 days on green feed, 3 days on chambers, and we did that 5 times. And so, we're looking about 40 measurements there, and we can obviously talk about some of the negatives there, but 40 measurements over that in that particular experiment. And then in the second experiment, we had lactating cows. We always expected that higher emission levels could be problematic in terms of these alternative sensors. And so we wanted to make sure that we pre-select cows as low, moderate, and high emitters and start milking them in that system. We were very and the word is aspirational or whatnot, to milk those cows 3 times a day in that facility, and we gave up on that real quick. But then there are 2X milking in there, and that had basically 12 late lactation cows, 3 days at 8 time points at 3 repetitions, so a total of 9 days per repetition. And that was both green feed chambers and this AgSense OptiWay system. Next. Oh, how do I do this here? Here we go, sorry. So the results here, we always get this sort of thing that, well, maybe intake's going to change. Yeah, we do lose intake when we put them on a truck and move them from the farm to our facility. But once they're in the facility, intake doesn't really change whether they're inside of a chamber or outside of a chamber. And we see that both here in heifers, and you'll see that in the cows in a second. But dry matter intake didn't change. We look at gas production. We're at 189 grams per day on green feed and 222 grams per day in the respiration chamber, which was different. CO2 was actually different. Methane yield and CO2 yield were also different as well. And so we had this methane production about 15% lower in green feed relative to the respiration chamber. But at the time, there were some other investigators thinking that maybe at higher emission levels, we could have some differences, a greater difference. And so this next study was the lactating cow study, where we had this OptiWay green feed and respiration chamber. Dry matter intake was equivalent, which is nice to see again. Our milk yield was equivalent. Energy-corrected milk yield was equivalent. 3.5% fat-corrected milk was equivalent as well across those 3 different methods. On milk composition, everything was the same except for true protein. For some reason, the green feed had a little higher true protein level in that. Milk urea nitrogen was also the same as well across treatment. So overall, not much difference on performance, which is what we want to see. In terms of yield, same thing. No difference in fat, true protein, lactose, and solids. Feed efficiency, no difference. So those are things we're just sort of monitoring to make sure that, these things are pretty comparable. And you have to keep in mind that we're putting animals in front of that OptiWay or the green feed. We do that it ends up being about 3-hour interval over a 24-hour period, 8 times. And, they're getting pellets there. We try to put, think about equal amount of pellets also in the chamber system. We try to make things as equivalent as possible, but, cows in a box, cows not in a box, obviously there's going to be some differences there. Gas production, though, we had quite a big difference here. Methane production, we had 394 on the OptiWay, 403 on the green feed, and 546 in the respiration chamber. On CO2, we had 8.21, 13.3 in both of those sort of head box units, and then a 15.6 in the respiration chamber. Definitely a big difference. The methane production was 27% lower in green feed relative to the respiration chamber. In terms of gas intensity, we're 12, whether it be OptiWay or green feed, 17 in respiration chamber. Whether that be from a milk perspective, and you can see the energy-corrected milk there. And gas yield, also a big difference, 15, 16 versus roughly 23. So these cows were certainly making a lot more methane. We're up there at 546, and some of our cows are certainly producing over 600 grams per day. And so we started to think about, what does that look like? We actually pre-selected those cows, and so people are starting to think about this, where you're going out, doing an experiment, and selecting low, moderate, and high cows, and we did that using green feed data. And we had clear separation. But when we put those low, moderate, and high cows inside the chamber, we could not see any difference. So that's concerning to us. We actually, when we reblocked them, we had different cows fall into the low, moderate, and high category. And that's a big deal because some of these, the percent reductions could certainly be different depending on what their emission status. We went and looked at the means. So these are the means, and you can see that temporal pattern. So when you're thinking about sampling, it really matters to think about when you sample using green feed. And you can see the difference there. Again, green feed was obviously lower than respiration chamber and consistently lower. And then I asked my student, can you pull out the high and low emitter cows on that? So 2593 was a high emitter cow, and she's upwards of almost 750 grams per day there post-meal. Whereas if you look, I wish this thing has a laser, does it? Yeah. So look at this difference right here. So her peak is right around whatever that is, 750. But when you look at what that was in the green feed, that's about 350. It's about half a difference at that specific time point for some reason in that particular cow. And so that's a big difference. So if I were sampling green feed here and not there, right, those are things we need to be thinking about. So as emission levels get higher, we get more and more concerned when it comes to using things like green feed. We looked at correlations. A lot of people are interested in these things, so I'm just presenting some of these things. We look at variable one is OptiWay, a respiration chamber, looking at methane, sort of compared to those two, and you get about 42% correlation depending on which one you look at there. The middle table, green feed by chamber, that's probably the most interesting one, 0.28 or 0.33, depending on the correlation they're using. And then at the bottom, OptiWay versus green feed, those were moderate at best. Almost done here. The CO2 correlation is not much different there. Again, relatively weak. And we had a company come up thinking about looking at relationships between performance variables and methane. And they're very interested in dry matter intake and methane, which they argued at 0.33 they were getting on green feed. And they're like, well, this should be higher. And when actually in our chamber data, we're getting a 0.7, 0.77 in terms of dry matter intake by methane, whereas with everything else, we're getting around 0.3. Right? So those correlations look really weak as when you use those kinds of systems as compared to a chamber system. Other things we're working on, we have some collaborators looking at the saliva microbiome as a way to predict emissions. That's actually the top half. They're looking at this using that 16S sequencing, using some of our data from those experiments, heifer and lactating cows, and you can see the R square there. We're revisiting milk fatty acids. We do a lot of fatty acid work we sample thousands of samples on that. And so pulling that data together to look at milk fatty acids as a predictor. Actually collecting the spectra, that's a new idea that Dr. Hostens has sort of thought about, and sort of mining that data for future use. Continue to test different sensors, we do that. We look at the relationship between behavioral data, comparing methane reductions in chambers versus green feed. So we have a study coming up with bromoform. We'll have those cows tested both in green feed and chambers simultaneously. And then streamlining data management. So we sort of share data more readily. Emil will talk about this later. I think, Karen, you're going to talk about this later? Probably. Emil is, so I'll bypass that. There's my team. Thank you. That's it.